Folks, to help repair my electrostatic loudspeakers, I've acquired a high voltage meter that measures up to 30 kilovolts, and it has a nice insulated front end with porcelain there. Unfortunately, the little probe I got for it, the banana plug here, doesn't fit in, which is a shame because it would have gone in there just nicely. So I'll have to figure out a solution to that. Probably somehow reduce the diameter of that, mill it down or something. Don't know yet. What it does is it reads the high voltage out here up to 30 kilovolts, but I'll very rarely go above about 6 or 8, so not a problem. But before I do anything, I need to convert it to 240 volts, because 115 volts is just terrible. It's a useless voltage. So what I'm doing is, now first off, you can see this is all the input resistances. It's got an input impedance of 1000 meg or 1 gig ohm, and that's all protected in there, which I was hoping it would be a bit more open, but to have a look. But I guess the beauty of, unless I disassemble it, which I don't really want to, unless I disassemble it, at least this keeps the dust out and prevents unwanted arcing or anything like that. And it has the little output here that goes into the little circuit board here, which is fed by a AC voltage from this transformer, and I'm assuming these two thin purple wires are the mains. Yes, they are indeed. But I need to see if I can change it to 240. 0, 100, 110, 117. Ah, here we go, down the bottom. 220, 230, 240. Ah, thank goodness. We just moved the 117 tapping down to the 240. That one there. And then I don't have to worry about step-down transformers. Having mains like that, just free like that, that's not very good. You can see that things have changed. This is not a good CE designed instrument. It's pretty terrible as far as mains goes. I'm going to add some extra zip ties to help protect. At least it does have a fuse, I'll give it that. That's something. But I need to find out which is the active and which is the neutral, because the fuse should be on the active side, not the neutral. And also this Yankee Doodle Dandy plug is not good. I can probably keep the fuse at 0.5 amp because, well, depends how easily it blows, but 0.5 amp should be plenty for 240 volts. The little circuit board here, the only reason for its existence is to power DC for the display at the front, which is a Techno design. Okay, XE1020KS. I'm assuming it will do negative voltage, but I don't know yet. I did notice that the plus sign on the front alternated between minus and plus, so it may well measure negative voltage, which would be good. Not that I'll ever need to do that. Everything I measure is always plus. Alright, so I'll go ahead, get the soldering iron and some zip ties and do this. You can see in there. We'll change this one here, and I'll meter out the active line. Alright, I'll do that. This high voltage meter is brand new, only been turned on once. Actually, new old stock. It was, from what I can gather, it was made about 10 years ago, but for some reason it never got used or sold or something, and so that's good for me, but I have to convert the voltage. As I say, 117 volts is useless. So at least it is multi-tapped, so that's good. So I can convert it. I wouldn't have liked to have had to use a transformer all the time. If I did, I'd probably stick one inside here. I do have a really small one that would have fitted in here and just hardwired it in, but this way I don't have to worry about it. Double check, make sure I've got it on the right tapping. It would be down the bottom, so down the bottom here, so it's a bit hard to get to, but we'll work it out. Now to put some zip ties and protect those mains looms. I don't know where my zip ties are, so I'll just use my usual wax cotton. I like the wax cotton. The wax cotton is good because it holds the knot and doesn't move because of the wax. It grips to whatever you're tying off. I think you can see there now. The mains wiring, instead of 117, is now on the 240 volt tap, and the 0 volts stays there. Fairly straightforward. Now we follow this down here, and if you notice here, this is the mains switch there. Also, wires are a bit loose. CE requires that if one wire comes loose, it's not to touch anything. That could cause somebody to be electrocuted, which means a mechanical join as well as a solder join. Even this isn't perfect, but it will do, I'm sure, so that if accidentally one of these come loose, it won't go anywhere except maybe to the chassis, which is grounded, or to the other mains wire, which case it would probably blow the fuse. So ideally, instruments should have 2 fuses, one in the active and one in the neutral, but not many people do that. Only reason I know all this stuff is because I was involved with the development of products at Varian, which later became Agilent, and we used to design and manufacture spectrophotometers and spectrometers and lots of other things. Everyone knows what a mass spectrometer is. We used to make them. In my job there, I got to know all about CE certification and everything required, and it's quite an expensive business. I just recently heard that the UK is abandoning their UKCA certification. I wonder why. There's a perfectly good CE certification that's recognised the world around, and the UK government wanted to go on their own. What a pack of dildo heads. Even Australia, we have our SA, Standards Australia, but even those we do follow a lot of the CE recommendations, and most of our products, like in the rest of the world, make them according to the CE guidelines. And this would not pass. And it doesn't have a CE mark on it. Alright, let's I think that's about it. I'm looking forward to being able to measure the high voltages on my quite electrostatic loudspeakers. It's been a topic for me for quite a while that I haven't been able to do it. I did design a little DIY voltmeter high voltage a while back, but I never got around to finishing it, and it wasn't readily available, the kit that I built. It's in the shed somewhere. And when I saw this on Fleabay, I just had to have it. It's such a nice unit. All right. Next thing to do is to change this to a proper plug. Right, I found a suitable plug, and it's labelled active, earth and neutral. So I sort of breathe and cut the lead off. Black is active, white is neutral, and green of course is ground. Now the local standard here is that the green yellow striped is ground, the blue is neutral and brown is active, but this I think is also accepted. This is a US standard. I'm hoping it's alright with 240 volts, but it should be. For some reason I think they're swapped. Yeah, active is going to the 0. I suppose it doesn't matter on the transformer itself, but what's on the switch, that's the important thing. The switch should be doing the active, switching the active. Well, it turns out the wiring is mostly okay. They actually switch both the active and the neutral, but prior to that it goes through some chokes and some, I think they're varistors, on the circuit board here, and there's a little tiny resistor that goes off to a capacitor and does something. Why it's getting a voltage from the mains via a small resistor and a capacitor, I don't know. That's a stupid idea, but that's the way it is. So long as the ground is properly connected, I guess I'll always be okay. Now you notice that they use a black wire for the ground here. That's totally wrong. It should be green, yellow, or even green. The main thrust is that the 0 volts is connected to the active, and now the 240 volts is connected to the neutral. So rather than redo that, I'll just label on the top here that that's the active at 0 volts, and neutral is at 240. It shouldn't make any difference on the transformer itself. The transformer's feeding 9 volts at 400 milliamp. That's what the winding is. I won't bother trying to trace out the circuit any more than what I've done. It's it is what it is. Alright, so I think we're right now. Just have to put this plug on. All done. So I'll turn it back on, put the cover on, and I'll probably use the variac just to make sure that it's all right. I think it should be. Right, plug into that variac, turn it on, and just so you can read it. I should be able to see that. 0 volts. Let's turn this on. Now, slowly turn it up. Right, we're getting a reading there, and it's only at 130 volts. 166, 208. Just leave it sit there like that for a little bit. What I probably should do is measure the secondary voltages just to make sure that they are what they're meant to be. 7.98, and it's meant to be 9 volts, so that's good. That means we go up to, let's say 230, yep, 231, and we should now get 9 volts or thereabouts. .86, so terrific. All right, let's go to 240. Our voltage should be 230, but it's actually 240. When I say should be, well, that's what the world is moving towards. 9.1, 9.2, that's perfect. Excellent. All right, so re-voltaging the Kikasui is now complete. That's all ready to go. Yeah, obviously the 0.5 amp fuse is more than sufficient. Ideally it should go down to 0.25 amp, but I'm sure it'll be okay. It's a fast acting fuse. Well, that's not meant to be a mains fuse. It'll do fine. Another thing with CE is that you're meant to use M205s, 20 by 5mm fuses. You don't use 3AG fuses. You just don't. And also they need to be recognised values. Now for mains fuses it gets a bit complicated, but normally they're known as delay fuses, and the best ones to get are by little fuse. I forget the series of fuse, I think 235 is one of them. I'm not sure, don't quote me. And they're delay fuse, but they're normally, or time fuse as they're correctly labelled, and what they do is they'll have the wording on them, T1A, time 1 amp, which means, and for mains they need to be ceramic, not glass. Glass fuses are not designed for mains. But of course, a lot of instances they don't worry about that. But that's how it should be for proper CE compliance. Anyway, there's lots of other things about CE that are interesting, and colours and gauges of wires. We had to change to completely UL wires from other stuff that we used at the time due to ratings and gauge sizes, and yeah, basically had to restock our complete wire inventory at work because of the change to CE, because prior to that we were using just normal Australian junk, which I mean, it worked fine, but it didn't cover the CE specifications. And which is why many of us got lots of free wire. They just had to get rid of it. And the new wire mostly come from companies like Alpha and Belden. They were the only ones that made the correct wire gauges. But when you're making a product, that's the least of your worries. And we made stuff in small quantities, so it wasn't as if a few cents here and there mattered. All right, I'll put the cover back on now. Off. Just extra protection. But unfortunately, the probe I've got, that doesn't fit in there, which is rather sad. I was thinking, why didn't they make that the typical banana size? But maybe they did that because they didn't want people putting in normal banana leads. which of course would be dangerous, so that could be. And this one here is just a Chinese thing that they just made it up. It'll be alright for me, but because I'm only going up to 10k at the most. But I need a new probe just here. I'm not sure the best way to go about this. It's not too important at the moment. So the idea is that plugs into there when I get the right size somehow, and I can measure my voltage on the quads. How good is that? Right. Alright, I look forward to using it. Until then, good night. Now, an idea that I do a lot is I place a bit of wire. It could be rope, but string is no good because it's just too fine. So you get something like this, put a knot in it so it doesn't come loose. Actually, it needs to be up a little bit. So when you put it like here, what you do is you get the loop, you shove it through around whatever you like, and you just tie it off so it doesn't go anywhere. Simple as that. So let's see, that's long enough, and there you go.